Hey guys, this is Vetri. In this video, we're going to see about Euler's path. A path in a graph is called as Euler's path, but it has to satisfy two conditions. The first condition is, so you have to visit all the edges in the graph exactly once, right? So you cannot repeat the edge, you cannot travel on the same edge twice. And the next one is, you have to visit all the vertex in the graph also. Okay, it's slightly different by comparing with Hamiltonian circuit. Okay, see, the first condition is you have to visit all the edges exactly once. You cannot travel twice on the same route. For example, so take the route like this, A to B. So either you have to travel towards A to B or else B to A. Okay, so you cannot travel twice on the same route, on the same edge. Okay, so that's the important condition. And the process is to check whether the given graph is having Euler's path or not. So simple, we are going to check the graph, whether the graph is having Euler's path or not. Okay, so that's the task. As per the condition, see, now I am going to check with this graph. Okay, so in this graph I have 4 vertices and 1, 2, 3, 4, 5, 6. 6 edges are there. So the concept is I have to visit 6 edges as well as 4 vertices. So you can visit vertices more than one time, that's not an issue in Euler's path. Okay, so let me check. So I am going to start travel from A to B and B to D and D to A and A to C, and see, if I choose C to B means my travel has to be end at this point, because I have to repeat the step, repeat the travel process either from B to D or else B to A. Though both the edges are already used, right? So I cannot. So I have failed here, and again I am going to check from C to D. See, check here. Is that possible? I don't think, right? So if I choose here, I cannot. So still this edge is pending, not visited. So I can come to conclusion that, so you can try with some other starting point also. Okay, so you can try, however definitely you will not get the Euler's path from this graph. Okay, so it's not satisfying. Now for this graph, see, just trying to find out the possibility whether it is having the Euler's path or not. Okay, so you can start from any node, but I am going to start from A. Okay, so I am going to start from A to B and B to D and D to A and A to C and C to D and D to E and E to C again, and I am going to C to B and B to E and finally E to A. See, I have visited all the vertices as well as graphs, so I have as well as the edges, right? So is there any pending? Everything have been visited, right? So just find out the route which I have traveled. A, and then I have visited B, and then D, from D to A, and again C, from C to D, and D to E, from E to C again, and again go to B, from B to E, and finally A. Okay, see, I have repeated the vertices. See, I have A 1, 2, 3 times and B 2 times. and D 2 times, C 2 times, E 2 times. That's not an issue when it comes to Euler's path. Okay, so that's it, and so this is how we are going to find out the Euler's path, and the question will be either you have to find out the Euler's path from the given graph, or else so you are going to find out whether the graph is having Euler's path or not. Okay, and about the Euler's path we are having some interesting facts. Okay, so let me explain. Here, the fact is, the problem name is Königsberg Bridge problem. Okay, in German 1942, they had a problem. They have built 7 bridges in city, and they had the problem like the condition is they have to visit all the areas in the city, and the condition is they have to visit the bridges exactly once. They cannot use the bridge twice at a time. Okay, and that's the condition, and still it's impossible to solve the problem, right? And after that problem, the mathematician name is Leonhard Euler. Okay, so from his name only we have got that path, that is Euler path. Okay, so he invented that, the graph theory. So using that nowadays we are solving many problems in graph theory. Okay, see, the thing is, you have to we can create the graph from the geographical view. Okay, so from this we can take, see, so here you can consider this as a map. Okay, and here we are having the river, and that problem is completely different. Okay, in that problem we had 7 bridges, and it's completely different. Okay, so here I'm having a different image. See, here I have 2 rivers, right? River 1 and river 2, and it's a branch of river 2. Okay, see, and here I have 4 bridges. Okay, the thing is whether you are having the Euler's path or not. So you are going to find out the graph from the given pictorial geographical view. Okay, see, here I am going to consider this area as A. Okay, and here it's completely it's a single region, right? I'm going to take this region as B, and here I'm going to take this region as C, and here I'm going to take this region as D. Okay, so let us consider these bridges as edges. Okay, so from A to B there is one edge, and from B to C and D we are having a separate edges, and for C to D we are having a separate edge, which means bridge. Okay, so from this graph we can make a graph. It's a pictorial graph, right? From this, so A, and by using, so we can name the bridge like E1, E2, E3, E4. Okay, from A to B I am using bridge E1, and from B to C I am using bridge name E2, and I am going to C. After that, from B to D also it's possible, right? With the bridge name E3, and from C to D it's possible to reach that by using bridge E4, right? So that's the concept. So from this we can find out whether it's having or not. So the problem is different. Euler's path problem is different. Okay, the condition is you have to visit the edge exactly once, and you can visit the vertex as many times you want. Okay, but the thing is we can make the graph from this kind of geographical image. Okay, so that's it, and actually it's not necessary to write all those things under Euler's path. Just for your reference I am explaining this. Okay, and thanks for watching. If you have any doubts on Euler's path, you can ask. The concept is simple. Euler's path is a path in a graph, and it has to satisfy the condition. The condition 1 is you have to visit all the bridges, all the edges exactly once, and then the second condition is you can visit vertices more than one time. That's not an issue. Okay, so for a single graph you may have many Euler's path. If you are having means, so we can have many Euler's path. That's not an issue. Okay, and thank you. Do subscribe.